So we are on the second day of a radian measure. So what we're looking at here is a radian measure is going to be defined by a formula that is going to be S equals to theta R. So theta, this here, if we look at it, you're always going to have a central circle because we're always going to start from the center of the unit circle, and we have a ray that's going to be spinning. And so if it's spinning, then if we spin it all the way there, it's going to make the arc length on there. And I just made that a little bit too long, so let me erase that. So if we have um, this that's pointing here, and it's going to spin all the way around this way. So it's going to form this angle right here, theta. And if the radius of that is going to be the same length as the arc length right there, this arc length right there, if they are exactly the same, then this one here is going to give us theta is going to be 1 radian. So if S is equivalent to 10 centimeters, and R is also equivalent to 10 centimeters, then we know that when you have this, you're going to divide that. And so you get 10 centimeters divided by 10 centimeters is equal to theta, and that's going to be 1 radian. So we know that theta will always, always, always be in radian when we're using this formula. If an angle is given in degrees, you have to change it to radians. And so this here is what radian measure is made, but it's the same thing as degrees. It's almost like 12 inches is 1 foot. That means that 1 radian is very close to 60 degrees. It's very, very close to. So here is 60 degrees right here. So here is 60 degrees, and it's 1 radian is very close to that. So everything else in the unit circle is still the same. You still have quadrant 1, 2, 3, 4, and in those quadrants, sign is positive and negative, depending on which quadrant we're in. Everything in the unit circle is the same, except for now we have 2 different types of measures, a degree measure for the angle or a radian on their measurement. So here you could convert by using dimensional analysis, whether you're going from degrees to radians and from radians to degrees. So this here is another way that we talked about before on there. And so if you look at it, once around the circle is 2 pi, which is a little bit more than 6.2 radians, and then pi over 2 is a little bit 1.58, very close to 1.6, and of course pi is 3.14. So going around the unit circle is almost a little bit more than 6.2 radians, which going around in degrees is 360 degrees. So that's the difference between radians and degrees. And so when we're looking on here, if I wanted to measure this, we could do what we did yesterday in the counting part. And so we want to find out where the radian measure is of 3 pi over 4. Anytime that it's divided by 4, I know it's going to be a reference angle of 45 degrees. So if it's a 45 degree, I'm going to be on that green cover right there. So I'm just going to change that. And so I am going to count by threes. This one here is always going to be starting my 0. I'm always starting at the initial place 0 radians. And then this is pi over 4, 1 pi over 4, and then 2 pi over 4, and then 3 pi over 4. And I could continue going around and having this 4, 5, 6, 7, and 8 pi over 4, which is 2 pi. But I don't need to go that far. I could stop right here, and that there is where the quadrant is going to be quadrant 2, and it's going to be approximately, well, it is 135 on there. And so if we continue with this one here, -8, the negative is still the direction in which we're going, and it's going to be -8 pi. So we could count by pi's on there. So if I go here, I'm going to have 1 pi, and then this one here is going to be 2 pi, and then 3 pi, and then 4 pi, 5 pi, 6 pi, 7 pi, and then 8 pi. So if you look at that, that's where it's going to fall there. And so it's going to be in the positive quadrantal, I don't know how that changed, quadrantal angle in the x-axis. positive quadrantal angle on the x-axis. So that's where that's going to be. It does not lie on any quadrant. And then here, if I have this, then this one here is the pi over 3. So I am going to do that in blue. The pi's over 3s are counted with the pi's over 6s. So I need to change this to 6. So I'm going to multiply that there, and I am going to get um, um, 6 here, but if I do it to the denominator, I have to do it to the numerator. So that's going to be 8 pi over 6. So I'm going to count starting at 0, and it's going to be 1 pi over 6, 2, 3, 4, 5, 6, 7, 8 pi over 6. So that's this one right there. And so that's going to be in quadrant 3. Quadrant 3. Okay, very good. And then the next one is going to be drawing. Now we want 3. Now notice how it doesn't have a degree symbol, so we are still in radian mode. So when I'm looking at this in radian mode is what color do I have here? And so I'm going to do it in none of these colors because it's not falling on any of them on there. It's just 3 radians. But I know that pi over 2, okay, I know that pi over 2 is equivalent to approximately 1.5 dot dot dot, very close to 1.6. And I know that this here is approximately 3.14. So 3 radians is going to be right about there. So this one here is in quadrant 2. So I know that that's where it's falling on that. And then this one is also radian. Notice how it doesn't have a degree symbol. That's 1.8. And then 1.8, again, this here is pi over 2, which is equivalent to 1.5, almost 9. And then this is 3.14. 1.8 falls in between there. So it's going to be approximately right over here. So this one here is also in quadrant 2. And then being able to look at this, now we're looking at find the length of an arc. So we're talking back about those problems that we had before, where you have an arc, the length of an arc there, that's S, and then the central angle is 52 degrees. So that's sort of like questionable data, theta. And then you have the radius R. And so one of the things that we have here is that that is your radius. And we're using this formula S equals to theta R. And we know when we talked about that, that's the angle, that's the arc length right there. They want to know what this arc length is here when the radius here is going to be 14 centimeters and the angle here is 52 degrees. The only problem is radius and arc length give you radian measure, not degree measures. So that's when you have to actually convert. So you're going to have to convert the 52 degrees using dimensional analysis, and you know it's going to be degrees in the denominator and pi in the numerator, and that's going to cancel out, and you are going to be able to reduce this to 13 pi over 45, and because you could divide by 4, it goes into both of them. So that is going to be your theta in radian mode. And in order to use that formula, we have to use that. So I still want to know what S is. And so the angle in radian mode is going to be the 1345 and then times the radius, which is going to be 14 centimeters. So this one here, S, is going to be approximately 12.7 dot 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 centimeters, because this is in centimeters, so this is also going to be in centimeters. This is a word problem, so we say the arc length is approximately 12.7 centimeters. And very good. And then here we have on the next one, we have that we have the radius of the circle, We want to find out what r is. They're giving us that the arc length, s, is going to be 70 centimeters, and then they're giving us an angle that is in degree, and we say, it has to be in radian mode, so I need to change it, okay? So then we are going to take the 125 degrees, and then we're going to put that over 1 times, and then degrees is going to be 180. We want to change it to radian. That's going to be pi. And it turns out to be that 25 pi over 36 is your angle. Once you actually reduce it, because you're dividing this by I don't know, 5? Yeah, you're dividing it over by 5. And then that's how you get this angle. So we use our formula, S equals to R theta. We know that S is 70 centimeters. I hate when this keeps doing this. 70 centimeters, and then the angle is going to be 25 pi over 36, and then we don't know what r is. So in order to solve this, what we do is we change this to 36 over 25 pi so that they could cancel, and then you do the same thing on this side. So it's going to be 36 over 25 pi, and then we put that over 1. And so then we could just calculate it, and we get r. Oh my goodness. And then we put that over r. Okay. Okay, and then we end up with, when you calculate it, you're going to get 32.0. I don't know why that keeps doing this. 9 centimeters. So what this one here is actually saying is that the radius I'm not even touching the screen, is approximately 32.09 centimeters. And there you go.